other anyone tried to solve this extra added step because a question like this yet? That'd be before I have paid. So typically, so you don't have to keep writing words out. This too is both ways. So you we say this was familiar. Possibly make more care to. Right, care. Believe that. So opposite directions, they can be away from each other, but they could also be towards each other. Okay, traveling. R1, okay, is moving at 17.0 meters. Put a direction in a given direction, we know the velocity. Okay. With the 900 or moving west with a map and to help you. And maybe if the okay, what might happen if they get they're going to get pushed forward. Behind this is them right here because this is where the first down marker is. So and heat of the moment or in a game, you're probably going to give them more momentum to get them down. I mean, and that happens at every level, college, high school. But in that case, you don't. But now you're adding them together because they're both. Okay. Okay. Notice in this case, we would add them. But if they're moving in opposite directions as opposed to the same one, what do you think you might do? If you're not adding them, chances are you're what? You're going to subtract them. Conservation means that there's something left over, whether it's something that gets added to that situation. Typically, these vehicles, they're going to crash into one another, and it's going to move one direction or the other. Okay. So the best way to do this is, since we say car 1 and car 2, we would have your information put, because problem, next thing you should do, and this is probably we've maybe said problems. The problem, write down, well, if you don't have papers that back, yes, you might have to answer, and you still get all of your. What do you suppose happens if it's an incorrect answer and there is no work? Okay. So what can happen is you can show some of your work, but maybe forget to, and then get the incorrect answer. Okay. So the best thing to do is makes the most sense. Goes over here. Okay. So we know about what is the velocity of car 1. Meters per second. What else do we know about car 1? So the mass is 935 kilograms. So we're solving momentum. You know, two things to solve for. Yeah, we need mass and the final velocity. We need to put letter P here because it's just a product. Okay, the mass velocity, like you identify. We know about car 2. Mass equals 1,210. Anything else that we know about car?
5, 8, M-S.
Okay, so that's a whole. Yeah, I like yeah, question mark. So, all right. So now, how do we solve for momentum? You do. What does the formula tell you to do? I think we're whispering it sometimes. Sounds like a plan to me. Okay, or the product. I don't know. Product equals. How do you right? Okay, it works. So we got 935 times what? Okay. So
Kimberly's got the answer.
1. 0.5. Okay. What pretty accurate. Point could be 1/8, could be 7/8. I don't know. That's certain. Okay. So what is the momentum of just one? So I'm notice on the right side velocity we're showing you how to do. So now this one here? Oh, so we'll put 0 there. Okay. So which one has the larger momentum? So keep in mind velocity. No, it wouldn't slow down. So our final step, add we got 5, 0. I can handle. Correct? Okay. 17. No. 1980. That was a good year. 1980. So here's our label, kilogram dash meter over second. Now, keep in mind, I recall, so be quiet. I thought that rude. I wasn't. Was I here?
You use kilograms instead of pounds.
Because it's the metric system.
Sorry, guys.
That's fine. So that's my question, but did that answer your question? We have velocity and then if in kilograms given in pounds, we have kilogram conversion. They have. Okay. Now we've got this done. There's some movement when it takes place. Yes. We subtracted those. Is. I'll just put that little sign there. But we need the number. We've got erase here because we solved for that over here. 15, 9, and 1, 7, 9, 6, 8, and yes, I happens. Car 1 is going to keep moving. Okay, so 1,000 meter over second. Direction. I was trying to think path or direction. This thing is moving over in the direction. This is the first time you've seen a problem. Back. Well, okay. All right. Can we? You know what? Okay. Which is a way of saying see the surface. How the swimming up and down something. Goes up and out of the with a velocity of 12.80 meters per second. So of course, all. Okay, we'll come back to that. Took second, 0.75 squared. Absorbs 80. Finally, what is the mass of what? So what do we know? So we've got a second. What else do we know? This have changed, but what else do we know? Can you be more specific? You can't, or because you need to be more specific. Thinking about that number. It's up. Accelerate. Meters per second. .1. Anything else? But it doesn't tell us what the is. It's going to tell you this labeling. No. If we're whispering, I can't hear that. It's the momentum. The variable for momentum. What's the variable for momentum? Okay? Now, content. We look at this problem here with a velocity of 12 seconds. Then, so this, it's and strikes with this. So what strikes with this momentum? Very, very specific. It's a what? There's choices. what are our variables? So if it's a or a fine, that's a fine velocity. Because asking, okay, the whale, or excuse me, how fast was the surface? Well, how is that? How fast the whale move? So that. So do we got unknown? Where do you think we can start this with? Where is it that or either one of them? To do both, is there one? Okay, the initial. How solve for the velocity formula would you to see where initial velocity? What's the okay? Difficult. Do would we want to put yes? With yeah. We've got this thing to do on the right side. Fourth, fifth, sixth, maybe. How do we can really miss that? Yeah, because we these. Well, remember we did. This, what is 1 times 12? What is 1 times negative VI?
Negative.
So now we're going to have this nice equation. If we multiplied with the 1, okay. times 20. And we get 5. We're not looking at anything yet because initial velocity. Brake skills. All by itself. But we have this 12.8 we got to get rid of. Just tell me. Minus 12.80. To the left side then? Not. Yeah. So now they're crossed out. We have the negative VI equals. So what do we have on the right side? And it really doesn't matter. You could type in 12.8 minus 5.75. Back down here. But is that it's now why is this wrong? Because it's negative. We don't have negative velocities. So multiply by -1, that makes them both positive. Was 7.85 meters per second. Then, just for time purposes, we solve for this one. How do we solve for the mass of this given information to you?
The T equals.
No. Okay, where do we see mass on our formula sheet? There's only one spot where you find. Where do you find the mass? It's on the side, but what formula is that? Yeah, your momentum formula. So, and we know the velocity. Your home. For our purposes, what we will do is just say this. Okay. 100 equals our mass 12.80 m. How do you get that? No. Yeah, you divide them numbers, but we got two numbers. Which specific one? That's correct. So divide each side by 12.8. That gives you 6.63. Okay. So I'm going to just a moment. Quick glance. Would you like a little maybe insight on one of these to help you out, or would you just like to process the rest of this class period? Okay. If you want to process, that's fine. Okay. The thing. High school, so it's a little more tough. It's certainly more rigorous. It is demanding. The rest of the time then is yours. Okay, we will catch up to you next time. Oh, before I forget, a momentum like in number 1, it doesn't always have in kilograms per meter per second. You can see it's in grams per meter per second. That's fine. And in cases you could have tons, like in number 3 where it's a conservation momentum. Let's see here. And then I think that's what you might have to have a little clarification on. Okay, we'll catch up to you next time. When are these papers due?
Tomorrow.
It's on Thursday.
Oh, who wants tomorrow? I heard tomorrow.
Diesel.
Wasn't me.
Oh, okay. So Thursday. We'll catch up to you next time.